So good evening guys. In the previous session we have discussed about the basics of Python. So in the basics of Python, so we have discussed about what are all the features of Python and what are the basic elements of Python, what are the variables, identifiers, key data types, keywords, and operators, flow constructs, functions, modules. Fine. So we have discussed about these stuffs and which act like basic stuff, like basic elements of Python, and where we are going to study machine learning algorithms based on Python language. So we have discussed about Python basics, Python fundamentals. Okay. So the next step towards learning machine learning algorithm is machine learning algorithms is studying about the basic libraries which are needed for running or executing any machine learning algorithm. Okay, so the basic libraries which are needed and which are very much important, which plays an important role while working with machine learning problems or machine learning field are three. Okay, so first one is a Numpy library, second one is a matplotlib, third is a pandas. Okay, so Numpy, pandas and matplotlib are the three basic and very much important libraries which works at the core in any machine learning problems. Okay, so in machine learning algorithms what we are going to use, so all those algorithms will at the core will going to use these three libraries. Okay, so these what are all the different functions or the attributes which are defined inside this library, so these things will be used in the core level of any of the algorithm in the machine learning field. Okay, so for that purpose we need to know how these libraries will going to work, because these are all the core things we need to study and we need to know because to understand the machine learning algorithms. Okay, so in the series the first one is Numpy library. Okay, so what is Numpy library? Okay, so what is Numpy and what are all the different functions or what are the different attributes which are defined in the Numpy library. So we shall discuss these stuffs in today's session. Okay, in tomorrow's session we shall discuss about the pandas library, and after tomorrow we shall discuss about the matplotlib. Okay, so these are all the important libraries which we have to discuss, okay, to know any machine learning algorithms. Okay, just a sec. Okay, so fine. What is Numpy? Okay, so Numpy is a Python library. So as I said, it is the first thing you have to describe about the library is it is a Python library. Okay, so Python library, and which is mainly used to work with the numbers and arrays. Okay, so Numpy is a Python library which is mainly used to work with the numbers and arrays. Okay, and that's why the name is called as Numpy. Numpy means numerical Python. Okay, so numerical Python in short will be called as a Numpy, and Numpy is a Python library which will be used to work with the numbers and arrays. Okay, and these numbers and these arrays can be processed in a different ways, and different analysis has to will be done with the help of these arrays and the functions which are defined in this library. Okay, so in a better way to understand the data set and to work on any machine learning algorithm. Okay, so Numpy is a basic library which is used to work with the numbers and the arrays. Okay, and its functions are also working in the domain of linear algebra and matrices, Fourier transform functions. So in these fields the functions which are defined inside this library will going to work. Okay, and one just a small history that you need to know is, so it was created in 2005 by Travis Oliphant named person. Okay, so it was created by Travis Oliphant named person, so in the year 2005. Okay, and it is a open source library which we can obtain publicly in the net. Okay, so and but one thing is for sure, when you install the any Python IDE along with that IDE, this is like these three libraries whatever I have mentioned, like NumPy, Pandas and Matplotlib. So these three libraries will going to be installed by default along with your Python packages. Okay, so along with your Python installation, Python package installation, these three libraries will also be get installed by default when you have started installing your tool, editing tool, or Python the tool which you are going to use to execute the Python programs. So whatever the tool it can be idle, it can be a PyCharm, it can be an Anaconda distribution, it can be only Jupyter Notebook, it can be only Spider, it can be Eric, it can be Autumn, so it can be anything. So if you are using any Python tool to execute the programs, to execute Python projects, so along with the installation of the IDE, so the libraries will also get installed by default by implicit installation. Okay, so as these are all the core libraries, but there are some libraries that are not installed by that package, but you have to install them using the commands from the external sources. Okay, so you have to use your Anaconda prompt, and you have to run a command to execute some instructions, and you have to install some libraries. Okay, so you will came to know that what are all such libraries that we have to install from the external source. So what are the default installed libraries? Okay, so basic libraries are these three, and these three will be installed by default whenever you install any editor tool, Python editor tool. So by that Python package itself, these libraries will get installed. Okay, so if you didn't get in this library in your system, or if you have the library in your systems, to check that, just execute this command. Okay, so open your Anaconda prompt and execute this instruction, like np.-version, okay, or numpy.-version, just numpy.-version. So just check this. If this library is installed in your system, then it will give you result like this. Otherwise it will give you an error like no module name numpy. Okay, if that is the statement, then the library is not installed in a system. Then in such cases you have to install that library in your system. Okay, so to install the library, to install this numpy package into your system, use the command pip install numpy. Okay, so pip install numpy, use this command. Open your Anaconda prompt, so like this. So you have to open your Anaconda prompt, and here, so whatever the statement is present here, so like this you have to type your command, and keeping the internet connection, you have to execute the command. Okay, just hit enter and connect your system to the internet. Okay, and then it's all done. So this library get installed in your system. Okay, so if it is already installed, then just execute once, verify that whether it is properly installed or not. So just import the library, import numpy as np, and execute the statement. If it is already installed, then it will give you a version. Okay, so as like in the previous session, we have seen how libraries can be used. Either can be a built-in library or can be a user-defined library. Both can be included, both can be verified that whether they have properly defined or properly imported into our program or not. So for that purpose, you have to include your import statement, and you can include that library functions or the variables or the any stuffs which are defined in that module. So you can just import all of them into your program by using the keyword import. Okay, so import, so to use the numpy library, use the word now import numpy. Okay, so as is used to have the alias name, generally numpy library will be used by the alias name np. Okay, so import numpy as np. So I imported the library and just check the version of the library. Okay, so to check the version, np dot hyphen hyphen underscore underscore version underscore underscore double underscore you have to give, and just hit enter. So if it is properly installed, then it will give you a version. Okay, so this checking of version is very much important, because in future some libraries need the specific version of the specific library. Okay, for that purpose you need to know how to check the version and how can you install the proper version or needed version. Okay, so this is the way that you can check which version has been installed in your system. Okay, so import numpy as np dot underscore underscore version underscore underscore. So if it is of any matplotlib library, just use it like matplotlib dot underscore underscore version underscore underscore. Pandas libraries like pandas dot underscore underscore version underscore underscore. Okay, so this is how you can check whether the library has installed or not, and if it is installed, what is the version of the library. Okay, so after checking that, we shall start working with the numpy library. How can you use them, what are the different functions or the attributes which are available with the numpy library, and how can you use them, what is the syntax, what is the purpose, what is the advantage. So all the stuffs we can discuss now. Okay, so import numpy as np, we have checked it, we have checked the version. Okay, so after that this is just another statement. If the first statement is properly executed, then only the next statement will go into execute. Okay, so that's why just include the second statement like print. If import numpy doesn't give you any error, that means it is properly installed. If it is properly installed, then the print statement will go into work. Okay, so if it is installed, then it will give you a statement like numpy installed already. Okay, so that's how you can check for the library. Okay, so after that we shall know what's the use of this numpy, and what are all the different functions. So all the stuff we shall discuss now. Okay, next as I said, so this is what the main library which is specifically used to work with the numbers and arrays. Okay, so as we have a similar data typed tool which we can use in Python to create similar variables, similar data typed variables. Okay, so as a like a numerical values or the arrays we can we can work with numerical values or the arrays using numpy, as I said, right? So but we have also like integer data type, and if you want to implement the array type of values, we can have use of list data type, right? Then what is the difference between list and numpy arrays? Okay, so what makes it different, so that even if we have the list in our hand, so what is the use of this introduction of numpy? Okay, so the reason is as said while explaining about the list. So list is a data type, or list is a collection data type where we can store heterogeneous data as elements of the list, right? Where if that is the case, then each and every element will going to store in a different location. Okay, and where in case of numpy all the elements should be of same data type. Okay, and in other words we can tell it like numpy arrays should be of homogeneous data type. Okay, so homogeneous data type in the sense all should be of same data type, that too numbers. Okay, specifically when we are specifically work with the numbers, and most of the time we use the numpy array to work with the numbers only, specifically numbers only. That it doesn't mean that we can't store the characters or the strings. We can store the characters or the strings, but most of the time we'll use the numpy array to work with the numbers only. Okay, but one thing is for sure, numpy arrays elements should be of homogeneous type. That means all the elements of the array should be of same data type. Either it can be an integer, either it can be a floating point, either it can be a decimal point, either it can be a character, or it can be a string, or it can be a list. So anything it can have, but all should be of homogeneous data type. Okay, all the elements should be of same data type. Okay, that is what the thing that has to be followed in numpy arrays. Okay, and the arrays in numpy are specifically called as nd arrays. Okay, so when you check the data type of the array object in numpy is called as nd array. Okay, so arrays or array object in numpy will be called as nd array. Okay, so that is the name you have to remember. Nd array is nothing but n dimensional arrays. Okay, so this is how this is what just the basic stuff you need to remember before getting into the numpy arrays. Okay, so then the next step is how to create arrays in numpy, and what are the different attributes and the functions with respect to these arrays, and how can you use them, what are the parameters, and what are all the results after using these functions or the attributes. So let us see that thing. Okay, while telling about the list and the numpy array, so list elements, the first difference is it can be the elements should be of homogeneous data type in a numpy array, but it can be heterogeneous in a list, and thereby the elements are stored in a different location in list and same continuous locations in numpy array, and for that purpose itself the accessing will be very fast in the numpy array, and in case of list it will be very slow. So the processing or the stuffs, so whatever the operations we want to do with the arrays will be done in a faster rate in numpy array. So that's why numpy arrays will be used whenever we wanted to use work with a homogeneous data, that too of numerical data. We used to have numpy arrays instead of the list. Okay, because of these features, like we can process it in a very faster rate, so thereby our task will be completed in a shorter duration of time. Okay, and the memory occupation also is very much less, and in a continuous way, in a easier way we can access the elements. Okay, so that is how numpy arrays can be used. So that is why it is more important, more better than that of list. Okay, so next we shall see how can we create numpy arrays. Okay, numpy arrays can be created using different functions. Okay, so mainly numpy arrays can be created using different functions, and these functions are array, arrange, ones, zeros. Okay, so these are the four important functions which are used to create arrays. Okay, create numpy arrays especially. Okay, array is one function, arrange is one function, ones and zeros. So these are the four different and important functions which are going to be used to create numpy arrays. Okay, and how can you use them? Okay, so first import the library, import numpy as np, and create a array object named as array. So this is an identifier, you can define it, you can give the name of this array object as per your wish. Okay, so you can give any name. Okay, this is equal to np.array. So the function should be called along with the numpy array, because these are all the functions which are defined inside this library. Okay, so as I said in the previous session, so simple calculator contains add function, subtract function, division function. So like that, these are all the functions which are defined inside Numpy library. If you want to use them, you have to use the dot operator along with the library. Okay, so library object, and it is imported as a NP. We can use the name NP. So NP dot array, and for this function we have to pass the parameter, that is the list of array elements. Okay, so we can give the list of array elements as a parameters to the array function, and these are all the elements of the final Numpy array itself. Okay, so once this statement has been executed, it is created that it is Numpy array has been successfully created, and once you execute this statement, Numpy array has been created and assigned and stored in the variable array. So if you print that, so then you will able to get the result like this. Okay, so this will contain the homogeneous elements, like homogeneous data typed elements as elements of as an items for the Numpy array, and it is created as a Numpy array. So if you check the data type of this array, so what happens? It will be like ND array. Okay, that is n dimensional array, Numpy dot ND array. That means this is the Numpy array which is of data type which is of type ND array. ND array is nothing but n dimensional array. So this is what the default data type of the Numpy arrays. Okay, so if this is the result, then it means that it is successfully created. Okay, so Numpy arrays has been created using a array function. So next, coming to the arrange function. So arrange function is similar to the range function what you have used along with the for loop, right? So for loop ಅಲ್ಲಿ range function ಅಂತ ಯೂಸ್ ಮಾಡಿದ್ವಿ ಅಲ್ವಾ. ಸೊ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಿದ್ವಿ range is a function which is used to generate a numbers, okay, or generate a sequence where we are going to give 3 parameters: start, stop and step. And start will give you the starting value, stop will give you the stopping value, and step will give you the increment value, like from start towards stop, how the value should be incremented or decremented, how the value should be modified. So that will be given in the step as a parameter. So likewise we can use the arrange function to create an array. Okay, so if you give only one value to the range function, so what does it mean? So is it a start value, stop value or step value? For a range function, if you give only one value, for I in range of 4, print I, stop value, right? So it will give you the stop value. So by default it will start from 0, and end value will be excluded. So it will generate the sequence of values like, and step value it is by default it is 1. So 0, 1, 2 and 3. So end value is generally excluded. Okay, so these are all the 4 values which are generated by the function arrange. Okay, so similar to the range function it will work. Okay, and these values will be assigned to the array variable, and this will be created as a Numpy array. Okay, so if we execute this, you'll get the result. Okay, if you check the data type even then also it will give you the result as numpy.nd array. So the data type of the Numpy array will always be nd array. Okay, this is how array function can be used and arrange function can be used to create the Numpy arrays. Okay, so next is zeros and ones. As the name itself suggests us, so zeros is a function which is used to create the array of zeros. That means all the elements is equal to 0, and ones is a function which is equal to create the number of ones. So like all the elements which is equal to 1. Okay, so and whatever the parameter you are going to give for these function like ones and zeros, so that will be considered as the count of values. Okay, you can also generate 2-dimensional or a matrix of 0 matrix or 1 matrix. Okay, so for that purpose you have to give 2 parameters, one is for rows, another one is for columns. Otherwise if you give only one value, then it is considered as only single dimension array which will be completely filled with zeros or ones. Okay, so let's just show that. Okay, so array is equal to np dot zeros of 4, so 4 values which is all equal to 0. So similarly ones value which is all equal to ones. Okay, so this is how numpy arrays can be created, and if we check the data type of the array, so it will be nd array. Okay, so this is how, these are all the 4 different methods where we can create the numpy arrays. Okay, so just note down this array arrange ones and zeros function. So these are the 4 different functions which are used to create the arrays. Fine. So next we shall see, so this is how, these are all the different ways of creating arrays. Okay, so next, as I said, the numpy array data type will always be nd array, which means for n dimensional array. So that means there can be a possibility of different dimensions of arrays we can create, right? So nd array, in the sense we can create n dimensional array. It can be ranges from 0 to n, right? So 0 dimensional array, 1 dimensional array, 2 dimensional array, 3 dimensional array. So likewise we can create a multi-dimensional arrays. Okay, so let us see how can we create a multi-dimensional arrays. Okay, so let us see how can we create a multi-dimensional arrays. Okay, so this is where here is an example where we can create a different dimensional arrays. Okay, so if you want to create single dimensional array, then just give the value, sorry, 0 dimensional array, then just give the value without any square brackets inside the parameter position of array function. Okay, just give a value. Okay, so if you want to create 1 dimensional array, just give include one square brackets inside the parenthesis of array function. Okay, so array function ke parameter agi 1 dimensional array kodbeku andre just include 1 square brackets. And in case of if you want to create 2 dimensional array, then mention 2, like you have to specify the 2 dimensional array. Okay, that is a matrix value. Okay, so if you want to create 3 dimensional array, just give the 3 dimensional array with this proper brackets separation. Okay, so just give values. Okay, so if you print them, print of A, print of B, print of C, print of D. Okay, if you print them, so you'll get the arrays. Just a sec. So I'll give it end with /n/n. So let's have a clear separation. Okay, so this is 0 dimensional array, this is 1 dimensional array, so this is 2 dimensional array, and this is 3 dimensional array. Okay, so this is how we can create a multi-dimensional arrays using same functions. Okay, fine. So just have a look at these functions. You can create a from 0 dimension to n dimension array using the functions which are defined inside the Numpy library. Okay, so and if you want to check the dimension of any arrays with any Numpy arrays, just use the statements like ndim. Okay, so ndim along with the array object. Okay, so if a is my array object, then use the attribute ndim. It will give you the dimension of the array. Okay, so Numpy array provides the ndim attribute that returns you the value of the dimension or the integer value that will tell that like how many dimensions that the array have been created. Okay, so if I want to check the dimension of array a, then use it like an a dot ndim. And if you want to know the dimension of b dot ndim, c dot ndim, d dot ndim. Okay, if you created this, a's value is a dot ndim value is 0 because it's a 0 dimensional array, b dot ndim value is 1 because it is 1 dimensional array, c dot ndim value is 2 because it is 2 dimensional array, and d dot ndim value is 3 because it's a 3 dimensional array. Okay, so let me just check it out. Here it is 0 1 2 3. So this is what the count of dimensions for the array object. Okay, so this is how we can create a multiple dimensional arrays. Okay, fine. So this is how we can create the multiple dimensional arrays. So these are all the default methods which can be used to create Numpy arrays. Okay, so array arrange ones and zeros, and we can create a multiple dimension from 0 dimension to n dimensional arrays. Okay, so to check the dimension of an array, use the attribute called ndim, array object dot ndim. Okay, so it will give you the dimension of the array. Okay, and in that dimension, so along with the dimension, if you want to access the data type of the array or shape of the array or total elements of the array or element size of the array, then you can use these different types of attributes. Okay, so data type, if you want to check the data type of the array like Numpy array along with like a type of variable. So along with that function, you can also use this special attribute which is defined inside the Numpy array. Okay, array object dot d type will give you the data type of the Numpy array, and array object dot shape will give you the shape of the array. Shape of the array in the sense if how many rows or how many columns, like how many samples you have in our data in our array. So that will be returned by the shape attribute. Okay, and array dot size will give you the total number of elements which is present in your array. So that will be returned by the function array dot size, and array dot ndim will give you the dimension of the array, and array dot item size will give you the element size, how many elements you have. So that will give you the element given by item size. Okay, and if you just execute this, so you'll see that what is the result. Okay, so print array will just prints the array, and data type of the array will be given by d type, array object dot d type. So that is what is the data type of the value which is present inside the array. So that will give you the data type of that will given by the d type attribute. Okay, so and type of array will always be nd array, and data type of the elements which are present in the numpy array. So that will be obtained by the attribute d type. Okay, so under shape of the array is returned by shape. So shape is nothing but how many rows, how many columns, so how many is that axis values. So that will be returned by the shape. Okay, and the total elements, how many elements total? 1 2 3 4 5 6 and 7 8 9. So total 9 elements will be returned by the size attribute. And dimension, how many dimension? So it is 3, 1 2 and 3. So 3 dimension element size will be 4. Okay, so this is how you can use different attributes of the which is obtained, which is defined inside the numpy library. Okay. Okay, so this is how we can create the numpy arrays, and you can create the different dimension, and you can access the properties of the array. Okay, so the properties of the numpy arrays. Okay, so next is how can we access the elements of the numpy array. Okay, so how can we access the elements of the numpy array? So accessing the numpy array elements is normally done by using the index numbers. Similar to the array strings, similar to the list, the elements of the array, numpy array especially, will be assigned with the index numbers. So there will be two ways of indexing. One is positive indexing and another one is negative indexing. So in both the indexing values we can access the elements of the numpy array. Okay, so numpy arrays can be accessed, that means numpy array elements can be accessed using the index numbers. Okay, and these index numbers, assigning the index values to the numpy arrays, will be called as the indexing. And this indexing process will be of two different types. One is positive indexing, other one is negative indexing. Okay, so positive indexing always starts from left to right, and it starts from the value 0. Okay, that means if 1 2 3 are the elements of my array, then indexing values will be start assigning from 1 towards 3. So starting initial index value is 0, second value is 1, third value is 2. Okay, so 0 1 and 2. So from the negative index value, okay, so negative index value row to column size. Okay, if 1 2 3 are my elements, if I am referring the negative indexing process. Okay, so negative indexing starts from right to left, from 3 to 1. Okay, so if these are my elements, if I use the negative indexing, negative indexing starts from right to left, and the numbering starts from -1, -2, -3, like this. Okay, -1, -2, -3. So likewise it will going to happen from right to left. So okay, so these are all the two different ways of indexing process. Okay, so positive indexing and negative indexing. Fine. So using these index numbers, you can access the elements of the numpy array. So just observe here, I'll just use both the positive indexing and negative indexing value to access the elements of the array. So if this is my array, so this is what the structure. So I have created 2-dimensional array. So I want to access, so at the basic level I just use the 1-dimensional array. Okay, okay, so just use it like array of 0. So array of 0 in the sense, so I am using the positive values, that means positive indexing, since I have used a value 0, so 0 means positive indexing starting from left to right. So left to right, array of first value is 0, that means array of 0 will give you the value 1. Okay, observe here. Okay, if I use same space, 1 will give you value 2. So if I use value 2, so it will give the value 3. Okay, so 0, 1, 2. So these are all the index numbers of the array elements, and using these index numbers we can access the array elements. Okay, so if I give the negative indexing value, then it will start from fetching from the last. Okay, if I use like -2, -1, -2, -3, so this is how the indexing values will be going to continue. Okay, if I use -2, 2 will be returned. If I give -3, first value will get returned. Okay, so this is how a positive and negative both can be used to access the elements of the numpy array. Okay, just take a note of this. Indexing indexing array, two ways of indexing: positive indexing and negative indexing. Okay, positive indexing and negative indexing. Positive indexing starts from left to right, and value starts from 0. Negative indexing starts from right to left, value starts from -1. Okay, just take a note of this example and that theory point. I'll give you 2 minutes of time. in the similar way, you can also access the two-dimensional array. Okay, so if we just I'll just try it. Okay, what happens when array of 0 is used? Array of 0 will give you the first dimension. Okay, so if you want to access both the dimensions, like only rows or on columns, both the dimensions, then use another set of brackets. Okay, then it will give you a single value. So array of 0, if you want to access only one dimension, then you can just use one pair of brackets, and if you want to access both the dimensions, then you can use the same another pair of brackets. Okay, so array of 1 will give you the second row. Okay, second row, and 0 will give you the first column value, so that means 3 will get returned. Okay, so this is how you can access the different dimension values. Okay, so using the indexing techniques. Okay, okay, and another important thing and the most usable thing in with respect to the indexing is slicing. Okay, slicing is nothing but, as the name itself suggested, slicing is nothing but cutting off or making it to pieces. Okay, so and this is what, like specifying the individual index numbers will give you a specific value, right? So what happens if you want to access a range of values or a specific set of values or complete row of values or complete column of values, or within row or within one dimension of array, so you can, if you want to access only a part of the array, so then in such cases you can take the help of slicing, and that is also happens using the index numbers itself. But here, instead of specifying only a specific index number to access the elements, we are going to specify the range of index values to get a part of this array. Okay, so either it can be a row, or it can be a column, or it can be in a single dimension, it can be just a part of the array. So if you want to access it, if you want to split it, then you can use the slicing technique. And slicing technique also can be happened using the index values. Okay, so for example, so if I want to access first part only. Okay, so this is a two-dimensional array, right? Let me just give an example with a single dimensional array. Okay, okay, so this is just a single dimensional array. Okay, so where I want the elements from 2 to 7. Okay, I want just these elements, these 6 elements. What happens here is I can access them, I can just access them using the index numbers. Okay, so how can I access? Just include the first element's index values. What is the first element's index value? It is 1. Okay, 0, 1. Okay, index value from 1 to till how much? Till 7 value I want. Okay, so what is the index number of the last element? 2, 0, 1, 2, 3, 4, 5, 6. So 6. So give 7. So if you want elements until 6, until index value 6, then give the value 7. So it will give you the values as expected. Okay, so this is how you can access, you can perform slicing. Okay, so you can specify the range of values, or another ways you can just specify the elements with the comma separation. Okay, so elements with the comma separation also you can access. Okay, and the slicing is nothing but we are going to just take a part of the arrays. Okay, so using the colon, like specifying the range of index values, we can slice the array. Okay, you can just piece the array, like as we are going to do it in string slicing, list slicing, right? So in the similar way, you can also do array slicing using the range of array index values. Okay, so this is how I can implement slicing technique in NumPy arrays. Okay, in this way. And here also so here also I can I have used specifying the index values in a square brackets, in a single pair of square bracket, and within that I have mentioned the index values. So in this if you specify this, you can also access the elements, okay, specific elements or specified element. Okay, instead of specifying the multiple square brackets, you can specify within a single pair of bracket, or within single pair of bracket if you specify the range of values, then you can get the part of the string. Okay, so this is how you can access, you can slice the arrays, NumPy arrays. Okay, just take a note of this, execute this slicing example. Here I have mentioned the index values, right? So index values in the sense, first will give you the first dimension, so second will give you the second dimension value, and third will give you the third dimension value. So if I specify like this, so then this array should be of 3 dimension. 3 dimension in the sense, first should be of x axis, that means row value. Okay, so it will access the first row, so first row will be this, right? Just a second, first row will be this, right? So next coming to the column. Okay, so coming to the next index will give you the column value, so column value in the sense this. Okay, 1 and 4. Okay, so 1 and 4, so these are all the first column values. Okay, and 0 in the sense index value, sorry it is 1, right? So start from 0 index value starts from 0, so 0 1, so second row second column. Okay, so second row it is, okay, second column values are this. Okay, and the 0th index value is this. Okay, so 0th index value, so what is the 0th index value? That is along the z axis, so you will get the, it will give you the value. Okay, so along x axis it is 1, along the y axis it is 1, along the z axis it is 0. So what is the index values of the what are all the values which is present in this index, so that will give you the result. Okay, so if you mention like for a simple case, just a sec, I'll give you the 2-dimensional array. Okay, so okay here observe, so this is just a 2-dimensional array, right? So 2-dimensional array in the sense, I'll just print it. Okay, so this is the 2-dimensional array, 2 dimensional array, I have given the parameters like 1 comma 1. 1 comma 1 in the sense 1 means 1th index row. Okay, 1th index row means, so the 0th row, sorry, the 0th row is this, 1 index row is this. Okay, that is second row. Okay, so this is column value is 1 in the sense index value is 1, that is second column values are these 2 and 7, right? So 2 and 7. So first index value 1th row is second row, index value 1 column is second column is this. So second row, second column, value intersect point is 7, so that will be returned as a value here. So what is the value which is present in this index, so that will be returned here as a result. Okay, so now hope you got the point. What is the value, what is the meaning of this point which is written in the square brackets. Okay, so it is not parameters, it is the index value. Okay, parameters in the sense that is the thing or the argument you are going to pass for the function, not as a index value position. Okay, square bracket ಅಲ್ಲಿ ಕೊಡಲ್ಲ, ಅವನ್ನ ಪ್ಯಾರಂಥಿಸಿಸ್ ಅಲ್ಲಿ ಕೊಟ್ಟರೆ ಅದು ಪ್ಯಾರಾಮೀಟರ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆ, ಪ್ಯಾರಂಥಿಸಿಸ್ ಒಳಗಡೆ ಕೊಟ್ಟರೆ, ಪ್ಯಾರಂಥಿಸಿಸ್ ಅಂದರೆ ಕಾಮನ್ ಬ್ರಾಕೆಟ್ಸ್, ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ಸ್ ಒಳಗಡೆ ಕೊಟ್ಟರೆ ಅದನ್ನು ಇಂಡೆಕ್ಸ್ ವ್ಯಾಲ್ಯೂಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆ, ಸೊ ಇಂಡೆಕ್ಸ್ ವ್ಯಾಲ್ಯೂ ಅರ್ಥ ಇಷ್ಟ. ಇದು ಫಸ್ಟ್ ಇಂಡೆಕ್ಸ್, 1 ಇಂಡೆಕ್ಸ್ ಇರೋ ವ್ಯಾಲ್ಯೂ ಒಂದು ರೋ, 1 ಇಂಡೆಕ್ಸ್ ವ್ಯಾಲ್ಯೂ ಇರೋ ಕಾಲಮಲ್ಲಿ ಯಾವುದಿದೆ ವ್ಯಾಲ್ಯೂ, ಸೊ ಅದನ್ನು ಇದು ರಿಟರ್ನ್ ಮಾಡುತ್ತೆ. ಇಲ್ಲೂ ಅಷ್ಟೇ, 1 ಇಂಡೆಕ್ಸ್ ಇರೋಂಥ ವ್ಯಾಲ್ಯೂ ರೋ, 1 ಇಂಡೆಕ್ಸ್ ಇರೋಂಥ ಕಾಲಮ್, ಸೊ ಅದರಲ್ಲಿ 0th ಇಂಡೆಕ್ಸಲ್ಲಿರೋ ವ್ಯಾಲ್ಯೂ, ಓಕೆ, ಯಾವುದಿದೆ ಅದನ್ನು ಇದು ರಿಟರ್ನ್ ಮಾಡುತ್ತೆ ಅಷ್ಟೇ. ಓಕೆ, ಸರಿ, ಇದು ಒಂದು ರೋ, ಸೊ ಇದು ಒಂದು ರೋ ಹೋಗುತ್ತೆ. ಸೊ 1 ಇಂಡೆಕ್ಸ್ಲಿರೋ ರೋ ಅಂತಂದರೆ ಸೆಕೆಂಡ್ ರೋ. ಸೊ ಸೆಕೆಂಡ್ ರೋನಲ್ಲಿರೋ ಸೆಕೆಂಡ್ ಕಾಲಮಲ್ಲಿರೋ 0th ಇಂಡೆಕ್ಸ್ ವ್ಯಾಲ್ಯೂ ಅಂದರೆ 10, ರೈಟ್? ಸೆಕೆಂಡ್ ರೋನಲ್ಲಿ ಬರೋ ಸೆಕೆಂಡ್ ಕಾಲಮ್ ಅಂದರೆ ಸೆಕೆಂಡ್ ರೋ ಅಂತ ಬರೋದಕ್ಕೆ ಇದು ಕಂಪ್ಲೀಟ್ ರೋ ಬರುತ್ತೆ. ಓಕೆ, ಸೆಕೆಂಡ್ ಕಾಲಮ್ ಅಂದರೆ ಸೆಕೆಂಡ್ ರೋನಲ್ಲಿ ಸೆಕೆಂಡ್ ಕಾಲಮ್, ಸೆಕೆಂಡ್ ರೋ ಅಂದರೆ ಇದು ಕಂಪ್ಲೀಟ್ ಪಾರ್ಟ್. ಓಕೆ, ಇದರಲ್ಲಿ ಸೆಕೆಂಡ್ ಕಾಲಮ್ ಅಂದರೆ ಇದು. ಓಕೆ, ಸೆಕೆಂಡ್ ಕಾಲಮ್ ಅಂದರೆ ಇದು ಫಸ್ಟ್ ಕಾಲಮ್, ಇದು ಸೆಕೆಂಡ್ ಕಾಲಮಲ್ಲಿರೋ ವ್ಯಾಲ್ಯೂಸ್. ಸೆಕೆಂಡ್ ಕಾಲಮಲ್ಲಿರೋ ಫಸ್ಟ್ ಇಂಡೆಕ್ಸ್ ವ್ಯಾಲ್ಯೂ, 0th ಇಂಡೆಕ್ಸ್ ವ್ಯಾಲ್ಯೂ ಅಂದರೆ ಇದು. ಸಿ 10 ವ್ಯಾಲ್ಯೂ ವಿಲ್ ಗೆಟ್ ರಿಟರ್ನ್. Okay, so that is how you can use the index numbers to access those specific elements in a different ways. Okay, so that's the next thing. Okay, so next we shall see reshaping of Numpy array. So reshaping of Numpy array in the sense, so how can we change the shape of the Numpy array? Okay, for that purpose first we need to know the shape of the array. So and that can be accessed like using the shape attribute. Okay, so and shape attribute should be used like this. Okay, shape will give you the shape of the array. Okay, so like as I said here, so shape of the array will be will return the value, the shape of the array, like how many rows, how many columns, how many z-axis values you would be having in a Numpy array. For a created array, Numpy array object ಅಲ್ಲಿ ಎಷ್ಟು ಡೈಮೆನ್ಷನ್ ಇದೆ, ಅಷ್ಟು ಡೈಮೆನ್ಷನ್ದು ವ್ಯಾಲ್ಯೂಸ್ ಎಷ್ಟೆಷ್ಟಿದೆ, ಸೊ ಅದನ್ನು ಇದು ಕೊಡುತ್ತೆ, ರಿಟರ್ನ್ ಮಾಡುತ್ತೆ. ಓಕೆ, ಆ್ಯಂಡ್ ಇಫ್ ಯು ವಾಂಟ್ ಟು ಚೇಂಜ್ ದೆನ್, if you want to change, like if you want to convert a 1-dimensional array to 2-dimensional array, if you want to change 2-dimensional array to 1-dimensional array, if you want to change 2D to 3D, so for to doing such things you can call the process as reshaping. Okay, and that reshaping can be done using reshape function. Okay, so using reshape function we can change the shape of the array. Okay, that is if I created the array that is called as x in 0 dimension and I want to change it to 2-dimension array. Okay, so before it was a 0-dimension array and I want to change it to 2-dimension array. So 2-dimension array ಇದನ್ನು ಹೇಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು, So use the reshape function. So mandatorily you have to pass two parameters. One is the array object, second one is the dimension shape. Okay, changeable, to which shape you want to change, so that shape you have to give. But one thing you have to remember, the size of the shape, modified shape should be equal to the size of the present shape or a current shape values. Okay, ಅಂದರೆ ಎಷ್ಟು ಇರುತ್ತೆ ಎಲಿಮೆಂಟ್ಸ್ ಕರೆಂಟ್ಲಿ ನಿಮ್ಗೆ ಎಷ್ಟಿರಬೇಕಿತ್ತು ವ್ಯಾಲ್ಯೂಸ್, ಎಷ್ಟಿದೆ ವ್ಯಾಲ್ಯೂಸು ಅಂದರೆ ಕೌಂಟ್ ಎಷ್ಟಿದೆ ವ್ಯಾಲ್ಯೂಸು, ನೀವು ಶೇಪ್ ಚೇಂಜ್ ಮಾಡಿದ್ಮೇಲೂ ಅಷ್ಟೇ ವ್ಯಾಲ್ಯೂಸೇ ಇರಬೇಕು. ಸೊ ಆ ಕೌಂಟ್ ಮ್ಯಾಚ್ ಆದರೆ ಮಾತ್ರ ನಿಮಗೆ ರೀಶೇಪ್ ಆಗೋಕ್ಕೆ ಸಾಧ್ಯ ಇದೆ. ಅಥವಾ ಮ್ಯಾಚ್ ಆಗಿಲ್ಲ, ಅಲ್ಲೇನಾದ್ರು ಎಂಟಿ ಸ್ಪೇಸಸ್ ಬರೋಕ್ಕೆ ಚಾನ್ಸಸ್ ಇದೆ ಅಂದರೆ ಆ ಶೇಪಿಗೆ ಅದು ಕನ್ವರ್ಟ್ ಆಗಲ್ಲ. Okay, so that is what the important thing you need to remember while reshaping the numpy array. Okay, so if I have 12 values in an array and I want to change it to two-dimensional array, I have to specify the number of rows and columns in such a way that I have to get the 12 elements total, okay, in that matrix. Okay, so for that purpose, what is the shape I could have? I can have 3 cross 4 matrix or 2 cross 6 matrix or 6 cross 2 matrix or 4 cross 3 matrix. ಯಾವ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಸೈಜಲ್ಲಾದರೂ ತೊಗೋಬೋದು. ಸೊ ಯಾವ ಸೈಜಲ್ಲಿ ತೊಗೊಂಡ್ರು ನಮ್ಗೆ 12 ಎಲಿಮೆಂಟ್ಸೇ ಬರುತ್ತೆ. ಸೊ ಯಾವ ಸೈಜಲ್ಲಾದ್ರೂ ನಾವು ತೊಗೋಬೋದು. ಓಕೆ, ಸೊ ಬಟ್ ದಟ್ ಸೈಜ್ ಶುಡ್ ಬಿ ಮ್ಯಾಚ್ಡ್. ಓಕೆ, ಸೊ ಆ್ಯಂಡ್ I have just taken the 4 cross 3 matrix I have created, and after that I have just executed it. So initially it was a single dimensional array, afterwards it become a two-dimensional array, and I have stored the reshaped array in Y. Okay, so initially it was a single dimensional array and afterwards it is a two-dimensional array. Okay, so this is how I can perform reshaping. Okay, fine. So next is data types. We can have any of the data types as an elements to the numpy array. Okay, so I can have strings, I can have integers, I can have float, I can have boolean, or I can have the complex as the elements of the numpy array, but all the elements should be of the same data type in a numpy array. And strings are used to represent, like as we have discussed in the previous sessions, we could have any of these data types, okay, as elements of the numpy array. Okay, but all should be of same data type. We can't have a heterogeneous values here. Okay, so that is what the thing you need to remember with respect to the data types of the numpy array. Okay, so next we shall see some of the predefined functions, so that we can use those predefined functions to benefit our projects. Okay, so ನಮ್ಮ ಪ್ರಾಜೆಕ್ಟ್ಸ್ ಎಲ್ಲ ಸ್ವಲ್ಪ ಶಾರ್ಟ್ಕಟ್ಸ್ ನೋಡಿ ಹೆಲ್ಪ್ ತಗೋಬೇಕು ಅಂದರೆ, ಸೊ ವಿ ಕ್ಯಾನ್ ಟೇಕ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ದ ಪ್ರೀಡಿಫೈನ್ಡ್ ಫಂಕ್ಷನ್ಸ್ ಇನ್ numpy array. Okay, so out of those there are certain functions are listed here, and apart from this there are plenty of functions which are defined inside the numpy library, which we can use them on the numpy arrays to calculate or to have just different versions or different and to have an analysis of the array. So for that purpose we could use any of the predefined functions which are defined inside the numpy library. Okay. Okay, and first in the list the first functions are view and copy. Okay, so view and copy are like similar, like appears like similar functions. Of course it is these are similar, but there is a small difference between these two functions. Okay, so as the name itself suggests us, view and copy will give you the copy of an array, right? So will give you the copy of an array, but the difference is when you have the copy of a numpy array using a view function, so whatever the changes you have made to the original array will be reflected to the copied array. But when you have created a copy of an array using copy function, then whatever the changes you have made to the original array will never ever gets reflected to the copied array. Okay, so that is the main difference between the copy and view method. So whenever you want to have a copy of a numpy array, like the effect of this will won't get you for a smaller size. When you have the hundreds of elements or thousands of elements, thousands of values in a numpy array, then you want to have a copy of it, then you can't just retype them again, and you can't have a copy. So in such situations you can just make use of these shortcuts, okay, these functions, and you can have a copy of these copy of arrays. Okay, so when you created a copy using copy function, then whatever the changes you have made, you're going to made in the original array will won't get reflected, it won't affect the copied array. Okay, and but if you have created the copy using view method, then whatever the changes you are going to made in the original array will definitely affect the copied array. Okay, so it is like a mirror, so it will affect the copied array. So the change, observe here, so I have created the array arr named array, and I have created the copy and stored in the variable x. Okay, and after that I have modified the original array, that is arr. Okay, arr is my original array, and I have just modified it, like first value is changed to 42, 1 to 42. So and afterwards if I print both the arrays, then only original array is affected, not the copied array. So copied array remains same, 1 2 3 4 5, when it is 1 2 3 4 5, it remains same. Okay, so afterwards if I do the same thing using view method, then whatever the changes I am going to made in the original array will going to affect in the copied array also. So observe the results here. Okay, so this is what the main difference between view method and the copy method. So both are used to have the copy of arrays, but the effect, afterwards effect is different. So whatever the changes you are going to made in the original array will affect the original array if you created a copy using the view method. Otherwise if it is created using copy method, then it won't affect. Okay, just make up note of this point, execute this example and have 2 minutes of time. Okay, so next thing is there's a next function is concatenate. Okay, so we have seen the function view and copy. So next is concatenate. So concatenate is a function which is used to join two numpy arrays. Okay, so if you want to join two numpy arrays, then use the function concatenate. So the syntax is concatenate, np.concatenate. For that you have to pass the parameter, and the parameters are two arrays which you have to combine, you have to join. So just use them as a parameters for the concatenate function. So afterwards execute them. So both the excuse me, both the values, both the arrays will get combined. Okay, so both the values will get joined. So joining is nothing but putting the contents of two arrays in a single array. So where we are going to do it using concatenate function. So we'll pass the sequence of arrays that we wanted to join using concatenate function. Okay, so you'll pass the those arrays as a parameters to the concatenate function. Okay, and after executing the statements, two arrays will get joined, will get combined. Fine. So this is what the simple case. If you want, and if you want to, you can join any dimensional arrays. Okay, like you can join 0-dimensional array, you can join 1-dimensional array, you can join 2-dimensional array, you can join 3-dimensional array along with a different axis. If you want to join along a along excuse me. If you want to join along x-axis, or if you want to join along y-axis, that means along rows or along columns, if you want to join, so that also you can mention so as a parameter along with the additional along with this parameter, like mandatory parameters, the arrays. So you can specify the axis, so where you are going to mention it, along which axis it has to combine. So okay, in more than one dimensional array, like in 2D, 3D, you have to mention the axis along which way it has to combine. But in case of 0-dimension or 1-dimension, it is not needed. It just there will be only one dimension. You can just combine them just by mentioning the array objects. Okay. In case of 2D, 3Ds, you have to mention the axis. So if it is 1, then along row it will be combined. If it is 0, then along column it will be combined. Okay. So if we execute this, so it will be rows will get combined. So otherwise, if it is 0, then columns will get combined. Okay, so columns will get combined. Okay, so this is how you can implement concatenate operation. Okay, okay, along different axes. Okay, so concatenate is a function which is used to join the numpy arrays. Okay, so view and copy to have a copy of arrays in different ways. So joining numpy arrays can be done using a concatenate function. Okay, next is split. Splitting can be done using the slicing techniques. Okay, so this is how like join ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಸ್ಪ್ಲಿಟ್ ಇರಲೇಬೇಕಲ್ವಾ. ಸೊ ಸ್ಪ್ಲಿಟ್ಟನ್ನು ಹೇಗೆ ಮಾಡ್ತೀವಿ, ಯೂಸಿಂಗ್ ಇಂಡೆಕ್ಸ್ ವ್ಯಾಲ್ಯೂಸ್, ಲೈಕ್ ಸ್ಪೆಸಿಫೈಯಿಂಗ್ ದ ರೇಂಜ್ ಆಫ್ ವ್ಯಾಲ್ಯೂಸ್. ಸೊ ಅದು ಸ್ಪೆಸಿಫೈಯಿಂಗ್ ದ ರೇಂಜ್ ಆಫ್ ವ್ಯಾಲ್ಯೂಸ್ನ ಯೂಸ್ ಮಾಡಿಬಿಟ್ಟು ಲೈಕ್ ಸ್ಲೈಸಿಂಗ್ ಟೆಕ್ನಿಕ್ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ಬೋದು. ಸೊ ಅದನ್ನು ಬಿಟ್ಟು ಮತ್ತೆ ದಾರಿ ಯಾವುದಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಯು ಕ್ಯಾನ್ ಸ್ಪೆಸಿಫೈ ದ you can make use of the array split named function to split the array. Okay, so you can specify array split named function okay, you can specify array split named function to split the array. Okay, single arrays. Okay, normally you are going to split single arrays, right? So single arrayna ನೀವು ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ಬೋದು. ಆ್ಯಂಡ್ ಎಷ್ಟು ಸ್ಪ್ಲಿಟ್ಸ್ ಆಗಿ ನೀವು ಸಪ್ರೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಅನ್ನೋದನ್ನು ನೀವು ಹ್ಯಾವ್ ಟು ಮೆನ್ಷನ್ ಇಟ್ ಆಸ್ ಅ ಪ್ಯಾರಾಮೀಟರ್. ಲೈಕ್ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಐ ವಾಂಟ್ ಟು ಸ್ಪ್ಲಿಟ್ ಇಂಟು 2. ಓಕೆ, ಜಸ್ಟ್ ಹ್ಯಾವ್ ಅ ಸಿಂಗಲ್ ಡೈಮೆನ್ಷನಲ್ ಅರೇ. ಓಕೆ, ಐ ವಾಂಟ್ ಟು ಸ್ಪ್ಲಿಟ್ ಇಂಟು 2. I'll just give a single dimensional array and I want to split. Okay, so 2 arrays will be splitted, right? So if I want to split into 3, So 3 arrays. Mm. 3 values will get splitted. Okay. Next, if I want to split into 4, okay, split it. Okay. So this is how I can split the array. Okay. Copying, joining, splitting. Okay. Next is searching. So searching array is nothing but, so this is the technique of searching a particular element in an array. That means whether a particular element or a value is present in your numpy array or not. So that can be searched using a method called where. Okay, so where is a function or a method which is used to search for a specific element in a numpy array. Okay, so that can be done using searching arrays. Like whenever you want to search for a particular value in a numpy array, whether it is present or not, so then you can just use the function where. So where you are going to search for the values, and you can return the result. Okay, so and the function is np.where. So you have to give a parameter as array object, and in that array object which value you are going to search, so that you have to compare. Okay, so if array value is equal to 4, so it will give you it will return you the index value where it is present. Okay, if it is successfully obtained, then it will return you the index values of this value. Okay, which is the element you are going to search for. So where it is present in your array, so that will be returned. So if it is present more than one time in your array, so all those index values will be returned. Okay. Excuse me. Okay, so this is how you can search a particular element in a numpy array. Fine. So you can just take a note of this. Searching element is done by using numpy like np.where. Okay, next operation is sorting arrays. So sorting arrays is nothing but, as the name itself suggests, sorting is nothing but putting the elements in a particular sequence, either in ascending order or in a descending order. You are going to sort the elements, right? So for that purpose, which is the method used? It is sort. So sort method will be used to sort the elements of the array, right? So the array object you have to pass as a parameter. So if you pass that, so then the array elements will get sorted. Okay. So this is how sorting can be implemented. And you can sort the elements of any of the data type. Like if you have given the character data type here as a elements of the numpy array, if you are given the boolean values as a data type for data elements of the numpy array, so all those stuffs can also be sorted, but the sorting order will be different in for different data types. Okay, so like for example, if you are given the number, it will be in ascending order. If you give the alphabets or the strings or the characters, then it will be in it will also be in ascending order, but where the ASCII values will be considered for those strings or the or the alphabets what you are going to use as elements of the numpy array. So if you are given the numpy array as a strings or the characters, then those ASCII values of those characters will be considered, and accordingly the array elements will get sorted. Okay, if you are given the boolean values, then generally false values will comes first, and afterwards true values, true elements, whatever is present, so those values will be comes in the list, so in the array. Okay, so this is how you can sort the elements. Okay, fine. So you can also sort a two-dimensional array. Fine. Fine. So likewise we have too many techniques. Okay, so likewise we will be having too many methods which are defined inside the numpy library, and we could use them as per our requirement. Okay, so for any of the library you are going to use in any of the machine learning algorithm, so those libraries will be having its own official websites where it is created by the developers who are developed this specific library. Okay, so whatever the updations, whatever the new methods or the new parameters or the new attributes which will be defined inside that specific library will be updated there, and we can get them, we can get the details of them in the official website, okay, of those libraries. Okay, so I have just mentioned a very few and important methods which will be used in a numpy library, and there are plenty of some more functions and attributes which are present in the numpy library. Okay, and you can just use them, you can just visit the numpy official library, official website once, and just check, have a look over how the official website is present and what are the contents will be having in that official website. So all those stuffs just visit once you get it. Okay, so I'll just show you the numpy library official website here. Okay, so this is what the just a sec. Just go to the browser. Okay, go to the browser and check for, just type numpy. Okay, for numpy it is which is the first library or the first site obtained. So this is what the numpy official website, numpy.org. okay, just click on it, so this library will get opened. Okay, so this is the official website of the numpy library here. So which is the latest version, so that is released, and what are all the previous versions, and any commands or the documentations or the discussion panel will be there, and the team community will be present, whatever the issues, so those are all discussed here, and what are the meetings, meetups, conferences, all those details you will get it here. Okay, so you can just have a meet and conversation or communication with the scientists. Okay, so we can have the detailed distribution, detailed package descriptions, so all those stuffs you can have a look in this official website. Okay, so observe here, so I'll be having whatever the basic methods. Okay, so what are the numpy packages, okay, how we can install them, what are the documentations. Okay, so guide, getting started, user guides. Okay, source repositories, installation files will be present. Okay, installation files. Okay, so API reference, user guides, so all those stuffs you can get it in the official website. Okay, so this is what all about the numpy library, and please practice more on the numpy arrays, because these are all the core things that we are going to use in future. and in the machine learning algorithms, because the core data values which we are going to give for any machine learning algorithm will be in the form of numerical values only. And to work with a numerical values, which is the important library is NumPy. So okay, you have to take a grip over this library, and whenever you think of something, you have to use the method. Okay, so to that extent you have to get practiced. Okay, so just practice over these NumPy arrays. Okay, so that's it for today's session. If you have any doubts in any of the concepts of today's